Mysteries of the Egyptian Pyramids, comprehensive analysis of construction, purpose, and hidden structures. The Egyptian pyramids, especially the complex on the Giza Plateau, remain one of the greatest mysteries in human history. These monumental structures were erected more than 4,000 years ago. They continue to inspire awe, and they spark endless debates about the capabilities of their creators. For the general public, the pyramids embody ancient wisdom, lost technologies, and even extraterrestrial influence. The mystery of pyramid construction begins with the most fundamental question: who built them, and how was this incredible undertaking accomplished without modern technologies? The notion of slaves exhausted by pharaohs persisted for over 2,000 years. But modern archaeology has definitively refuted it. Studies of the worker settlements, cemeteries, and analyses of materials from construction sites have created an entirely different picture. This was a highly organized national project. It was made possible by the power and sophisticated management system of the pharaonic state. A foundational shift in understanding pyramid construction relates to the composition of the workforce. Archaeological finds made in the late 20th century, primarily in the workers' settlement south of the Sphinx, directly indicate that the builders were not slaves, they were free citizens. These people belonged to the class of artisans and peasants. They fulfilled their share of state taxes through labor service. This was not forced labor, but a form of duty similar to modern civic obligation. The evidence for this is numerous and convincing. In the workers' cemetery, burials were found that testified to high social status. Some were buried in the fetal position. This was a prerogative of the nobility, not slaves. The workers' diet was significantly better than average. Bone analysis shows consumption of large amounts of protein. This was sufficient to maintain the health of hundreds of thousands of people. Such provision would have been impossible for slaves. They received decent sustenance, daily rations of bread and beer. This is confirmed by records and documents, such as the Mirror Papyrus. Thus, the popular image in mass culture of forcibly laboring slaves is a product of erroneous interpretation by ancient authors. For example, Herodotus, his accounts of millions of people working should be regarded as exaggeration. The size of the workforce needed to build the Great Pyramid of Khufu is estimated in the range from 14,000 to 40,000 people. This depends on the calculation model and assumptions. Although these figures seem enormous, they were quite feasible for the powerful centralized state of ancient Egypt. The principles of organizing the work process were likely based on principles similar to those used in constructing other large objects. For example, Notre Dame Cathedral in Paris. There, it took about 200 years and thousands of craftsmen. The workforce was organized into large groups, such as files. They, in turn, were divided into smaller units, managed by experienced leaders. Inscriptions such as Friends of Khufu or Drunkards of Menkaure were found on rocks. They testify to the presence of work groups with names and collective identity. The project was divided into stages. While one group worked on the main structure, another could handle internal chambers, and specialized masons simultaneously prepared blocks and quarries. This modular organization allowed for efficient coordination of large groups. The central element of pyramid construction logistics was the Nile River. It provided access to remote material extraction sites, and the possibility of transporting them to the construction site. A recent study used satellite imagery and geophysical data. It allowed for the reconstruction of a previously unknown waterway. This ancient branch of the Nile, named the Pyramid Branch, this river was active during the reign of the 4th dynasty pharaohs. It flowed in close proximity to the Giza Plateau and many other pyramid complexes. It served as a kind of highway, along which barges with materials moved to the plateau. The Mirror Papyrus, the oldest written sources in the world, detail how his team transported white limestone from Tura on barges. They reached their destination after 2 to 3 days of travel. Without this water system, which would have been impossible without artificial canals and reservoirs, pyramid construction on such a scale would have been absolutely unthinkable. The technologies used for stonework were adapted to the properties of different rock types. For soft local limestones, which made up the main volume of the pyramid, copper chisels and drills were used. They were moistened with abrasive quartz sand. For harder rocks, such as granite from Aswan or red quartzite, much more time and effort were required. Stoneworkers used hard basalt stones to chisel grooves around the block, after which wooden wedges were inserted into them. They were then soaked with water. The expansion of the wood created enormous pressure. It split the stone along the intended direction after separation from the massif. The blocks were fitted on site to match their neighbors. The density of the block joints, often described as ideal, actually has its limitations. Although gaps can be minimal, they are still filled with mortar of gypsum and clay. Claims that not even a knife blade can be inserted between the blocks are likely an exaggeration. Although the quality of execution is impressive nonetheless, the transportation of the heaviest blocks, which could weigh up to 70 tons, was another serious challenge. Blocks from Aswan, including 5 giant granite beams over the king's chamber, each weighing 60 tons, were transported along the Nile on rafts. On land, they were moved on wooden sledges. Here, a simple but ingenious idea played a key role. It has been confirmed by experiments. Physicists from the University of Amsterdam established that wetting the sand in front of the sledges in a certain proportion creates capillary bridges between sand grains. This is about 2 to 5%. It makes the surface significantly stiffer and reduces friction. This allows the pulling force to be reduced by about half. This technique is confirmed by ancient drawings. For example, in the sarcophagus of Giza Plateau, there one person pours water on the sand in front of the sledges, on which a huge statue is being dragged. Lifting the blocks to the height of the pyramid was the most complex part of construction. Most Egyptologists agree that external ramps were used for this. However, the specific configuration of these ramps remains a subject of debate. The earliest and simplest model is a long straight ramp. It runs parallel to one side of the pyramid. However, this theory faces a serious argument. To lift to the height of the Great Pyramid, such a ramp would require a volume of material comparable to the volume of the pyramid itself. This would leave huge traces. None have been found. More complex variants include spiral ramps. They would wrap around the pyramid from the outside, or zigzag ramps. They would go diagonally, changing direction. These designs required less material, but created problems with maintaining the accuracy of the pyramid's shape at upper levels. Recent computer models suggest a more sophisticated approach. This is a temporary spiral hoist. It is created by skipping perimeter blocks. This allows building the pyramid without external traces after completion. In addition to ramps, for lifting the last blocks to the very top, levers and supports were likely used, since it is here that the greatest precision is required. Thus, pyramid construction was not the result of one mysterious discovery, but the fruit of years of engineering knowledge development, systematic labor organization, and effective use of available technologies. Now let's examine the key aspects of construction in detail. The workforce consisted of free citizens. They worked under a system of labor service. These people lived in specially built settlements. They were well fed and received medical care. Logistics relied on the Nile River. The ancient pyramid branch waterway provided direct access to the Giza Plateau for material transportation. Transportation included moving blocks over land on wooden sledges. They were wetted with water to reduce friction. Stone processing for soft limestone used copper chisels and abrasive sand. For hard granite, hard basalt stones were used for grooves, wooden wedges and water for splitting. Lifting blocks involved the use of external ramps. These were straight, spiral or zigzag variants. For upper levels, possibly the use of levers and supports. Overall, the analysis of construction technologies and labor organization shows that the pyramids are the hallmark of the highest engineering and administrative power of ancient Egypt. They demonstrate how a centralized state could mobilize enormous resources, organize the labor of millions of people, and solve the most complex logistical and engineering tasks to realize an ambitious religious and political project. Now let's move to constructive theories, from external ramps to hydraulic lifts. Although the theory of workers and ramps is dominant, it is supported by a significant amount of archaeological data. But it is not without its problems. The main questions concern the scale and traces of a large external ramp, as well as the efficiency and precision of lifting the heaviest blocks to the upper levels of the pyramid. These gaps in understanding have stimulated the development of alternative theories. They seek to find more elegant or logically consistent solutions to the construction mystery. These hypotheses can be conditionally divided into three main categories: theories related to materials, that is, pouring; theories related to ramp design, that is, internal spiral ramp; and the most radical, related to the use of water, that is, hydraulic system. The most famous alternative theory concerning materials is the hypothesis of Joseph Davidovits. He believes that the pyramid blocks were not quarried, but formed by pouring a mixture of limestone and geopolymer binder into wooden molds. The main argument in favor of this theory is the remarkable precision of block joints. According to proponents, it is practically impossible with manual processing. If the blocks were cast, their surfaces would be perfectly flat. This easily explains the tight fit. Support for this theory, in their view, comes from studies by Mitchell Barsoom and his colleagues at Drexel University. They found amorphous structures in the microstructure of some limestone block samples, air bubbles, and silicon dioxide nanoparticles. These elements, they say, do not occur in natural limestone and indicate artificial origin. However, this theory faces strong and consistent resistance from geologists. Critics point out that the sample used by Davidovits was taken from the known Malkadam limestone formation, and its microstructure is fully consistent with natural origin. Moreover, the geological map of the Giza Plateau clearly shows the presence of quarries from which blocks could have been taken, and there are no signs of geopolymer concrete production activity. Thus, despite its apparent elegance, the pouring hypothesis lacks sufficient geological and archaeological evidence, and is not accepted by the scientific community. The second category of alternative theories focuses on ramp design. If the standard model assumes a huge external ramp, then the internal spiral ramp theory offers a solution to this problem. It was proposed by French architect Jean-Pierre Houdin. According to this hypothesis, an external straight ramp was used for constructing the lower levels, but for the upper floors, an internal spiral ramp was used. It was located inside the body of the pyramid. Blocks were lifted along this internal ramp, and after construction completion, the materials for the external ramp were recycled and used for erecting the upper rows of the pyramid. This theory is attractive for its economy and logical consistency, since it explains the absence of traces of a large external ramp on the plateau. Supporting evidence for Houdin's theory includes some density anomalies. They were discovered during gravimetric and radar studies of the pyramid. For example, microgravimetric measurements showed that the four edges of the pyramid have lower density than the rest of the body. This could indicate the presence of hidden voids or less compactly laid blocks, which is compatible with an internal ramp. Additionally, some unusual niches and recesses inside the pyramid, such as the hole on the northeast corner, could be interpreted as places for installing cranes. They are necessary for rotating heavy blocks 90 degrees. This is a key element of Houdin's model. Nevertheless, Houdin's theory is subject to serious criticism. Its main opponents, such as Egyptologist David Jeffries, call it fantastic and extremely complex. Critics point to the lack of direct archaeological evidence for such a mechanism in any other pyramid. and the technical difficulties associated with moving giant granite beams along such narrow and winding paths. Without direct evidence, such as ramp traces inside the pyramid, the theory remains hypothetical. The most radical and potentially revolutionary alternative theory is the hypothesis of a hydraulic system. It was proposed by researchers led by Xavier Landreau and Guillaume Piton. This concerns the step pyramid of Pharaoh Djoser and Saqqara. This theory, published in the peer-reviewed journal PLOS One, claims that a complex engineering system was used for pyramid construction about 4,670 years ago. It was based on controlled water use. According to this model, the ancient Egyptians built a dam known as Giza Plateau to capture seasonal water flows from surrounding valleys. This water was then directed into a system of treatment facilities known as the Deep Trench. There it was cleared of sediments and contaminants. The purified water then entered two vertical shafts. They are located under the pyramid itself, through cycles of filling and emptying these shafts using floats. Heavy stone blocks could be raised and lowered, like in a water elevator. This allowed building the pyramid in a wave-like manner from the center to the periphery. This theory has the potential to radically change our understanding of ancient Egypt's engineering capabilities. It takes it far beyond traditional ramps and levers. It explains how very heavy blocks could have been lifted, and uses skills already known to the Egyptians in hydraulics, such as canal construction and navigation. However, like any radical hypothesis, it requires confirmation. The main drawback at present is the lack of direct archaeological evidence for mechanical parts of the system. Valves, levers, pipes, everything is based on interpretation of existing architectural and geological data. Nevertheless, the authors emphasize that their hypothesis is a test. It can be confirmed or refuted by further research, and it opens a completely new direction for studying ancient Egyptian engineering. It is important to note that this theory currently applies only to the step pyramid, and does not extend to the Giza pyramids. For them, traditional methods are still considered more likely. Thus, the dominant theory of pyramid construction is based on established facts and understandable technologies. Alternative hypotheses represent attempts to find more perfect solutions to obvious problems. The pouring hypothesis challenges the most fundamental assumption about how blocks were made, but fails due to lack of geological evidence. The internal spiral ramp theory offers an elegant solution to the external ramp problem, but so far lacks direct archaeological confirmations. The hydraulic lift hypothesis for the step pyramid is the most exciting new direction. However, it is at an early stage and requires serious verification. These theories are important not so much for replacing the main model, as for identifying gaps in our knowledge and stimulating new, more thorough research. Now let's describe the theories in more detail. The dominant theory relies on external ramps made of earth and debris for lifting blocks. It is supported by numerous archaeological finds, including small sections of ramps on the Giza Plateau. But questions remain about the design of a large ramp, absence of direct traces, and difficulty of lifting the heaviest blocks to upper levels. The geopolymer concrete theory, or pouring, assumes that blocks were formed by pouring a mixture of limestone and binder into wooden molds. It is supported by high precision of block joints, and more or less is indicating artificial stone structure. But against it is the lack of geological evidence for artificial origin, presence of quarries on the Giza Plateau, and criticism from geologists. The internal spiral ramp theory speaks of lifting blocks in a spiral inside the pyramid body for upper levels. It is confirmed by microgravimetric anomalies, unusual niches in the pyramid, an economy of material recycling, but against it is the lack of direct archaeological evidence, and complexity of moving giant granite beams along internal paths. The hydraulic system theory for the step pyramid assumes the use of a water elevator for lifting blocks using floats and control shafts. It relies on interpretation of Giza Plateau as a dam, deep trenches treatment facilities, and hydraulic operating principle. but against it is the lack of direct archaeological evidence for mechanical parts of this system, and limitation of application only to the step pyramid. Say secrets are becoming increasingly complex and scientific. Construction mysteries are solved through systematic study of archaeological data and application of advanced technologies. Purpose mysteries, although provoking speculation, ultimately find explanation in the context of ancient Egypt's religion and culture. The most captivating mysteries, however, relate to internal space, and it is here that we stand on the threshold of perhaps the most important discoveries of recent decades. The future of pyramid studies is the future of interdisciplinary science, where Egyptology, archaeology, physics, geology, and engineering work together to answer questions that have intrigued humanity for millennia. Now let's move to the question of purpose and symbolism, from Pharaoh's tomb to astronomical map. Although the mysteries of pyramid construction concern questions of how they were built, the mysteries of their purpose and symbolism touch on the question of why. Academic understanding of pyramid purpose is based on numerous archaeological finds, texts found inside pyramids, and deep understanding of ancient Egypt's religious and cultural practices. The main, indisputable function of pyramids is to ensure the pharaoh's safe transition to the afterlife and his eternal existence there. They were not just tombs, but complex ritual complexes, intended for performing rites aimed at resurrecting and deifying the pharaoh. The architecture of the pyramid complex was carefully designed to fulfill this function. The pyramid itself symbolized the primordial mound, from which, according to Egyptian myth, the world arose, as well as the sun's rays, along which the pharaoh's soul was to ascend to the sky, to unite with the god Ra. The internal space of the pyramid was not empty, but consisted of a series of corridors and chambers, each with its own ritual significance. Corridors, such as the Grand Gallery, served as routes for carrying the pharaoh's body to his final rest. Chambers, such as the king's and queen's, were intended for placing sarcophagi and ritual belongings. Air shafts exiting these chambers were directed at specific stars. This emphasized the pharaoh's connection with celestial bodies. The entire complex also included adjacent temples, valley and upper, and places for burying boats associated with the pharaoh. This testifies to belief in a journey across the celestial sea. Texts found in other pyramids, such as the pyramid texts, which appeared during the 5th dynasty, contain prayers and spells. They are intended to help the pharaoh's soul in his journey through the afterlife. This confirms the funerary function of these structures. However, in addition to their funerary function, pyramids also served as an important tool for expressing the pharaoh's power and his connection with the gods. They were gigantic signs of the state's wealth and might, capable of commanding the labor and resources of the entire country. Pyramid construction began immediately after the pharaoh's accession to the throne, and continued throughout his life, symbolizing his earthly rule and his aspiration to immortality. The placement of pyramids on the west bank of the Nile, where the sun set, was symbolically significant, since the west was considered the land of the dead. Thus, the purpose of pyramids was multifaceted. They were simultaneously a tomb, and a symbol of power, and a religious center, and a tool for managing society. Despite the clear academic understanding of pyramids' main function, many people and history popularizers see something more in them. These exotic theories often arise from a desire to find in pyramids evidence of highly advanced but now forgotten civilizations, or extraterrestrial intervention. One of the most famous such theories is the idea that pyramids served as energy stations, or resonance chambers. This hypothesis was popularized by engineer Christopher Dunn. He claims that the pyramid was a device for generating electricity. According to this theory, the quartz granite in the king's chamber has piezoelectric properties. They generate electricity under mechanical stress, for example from earthquakes. The Grand Gallery could act as a resonator, amplifying sound waves, and a special design could convert this energy into electricity. Other versions of this theory suggest that the pyramid could use water from underground sources to create water turbines or generate hydrogen ions, despite its apparent scientific nature. This theory has no archaeological evidence. The internal contents of pyramids, including sarcophagi and ritual items, fully correspond to their purpose as tombs, not industrial objects. Moreover, generating significant energy would require complex mechanical and electrical components. None have been found. Another popular theory links pyramids with astronomy, but with a completely different meaning. Instead of serving as points for observing the sky, like modern observatories, pyramids are seen as devices for receiving or transmitting certain cosmic or earthly energies. The pyramid shape, in this view, is an ideal antenna or resonator tuned to specific frequencies. There are other, even more exotic hypotheses, such as the alien theory. It is popular thanks to Erich von Daniken's book Chariots of the Gods. The book suggests that pyramids were built with extraterrestrial help. There is also the theory that pyramids were created not by Egyptians, but by representatives of the legendary Atlantis civilization, or another highly advanced culture that existed long before the pharaonic period. It is important to understand that these pseudoscientific theories have deep roots in history and are often linked to racist and biased worldviews. The idea that such monumental structures could only be created by a race of white people or aliens has historically been used to deny the ability of African civilizations to create complex and highly developed societies. These theories are often part of a broader ideology. It seeks to whitewash history and discredit the achievements of black peoples. The popularity of these ideas among part of the population also reflects general distrust of official history and its representatives, as well as a desire to find something more mysterious and esoteric in the past than a simple description of human history. Thus, when we speak of pyramid purpose, we must draw a clear line between scientifically grounded understanding and speculative theories. The main, indisputable function of pyramids is tombs for pharaohs, serving for their transition to the afterlife. Their astronomical orientations were ritual and symbolic, helping to establish a connection between the pharaoh and the gods. Theories about pyramids' role as energy stations, antennas, or evidence of extraterrestrial intervention have no evidential basis and should be regarded as part of popular culture, not as reliable history. Understanding the true purpose of pyramids is no less fascinating than any of these mysterious theories, since it opens to us the complex and multifaceted world of religion, power, and culture in ancient Egypt. Finally, the most captivating chapter concerns astronomical mysteries, scientific explanations, and speculative theories. One of the most exciting and often discussed mysteries of the pyramids is their evident and striking astronomical orientation. The Great Pyramid of Khufu is aligned to the cardinal directions with incredible accuracy. It deviates by only a few minutes from true north. Additionally, some internal elements, such as the air shafts in the king's chamber, were directed at specific stars. This, combined with the Egyptians' rich astronomical knowledge, has spawned numerous theories that pyramids serve not just as tombs, but as astronomical maps, calendars, or even observatories. Analysis of these theories shows a clear division between serious scientific research. They provide convincing explanations, and speculative theories. They are often devoid of evidential basis and based on interpretation of coincidences. Scientifically grounded studies show that the ancient Egyptians indeed possessed deep astronomical knowledge and used it to achieve precise geometric and ritual orientation of pyramids. To determine the direction to north, they could not rely on modern magnetic compasses, but used methods based on observing the motion of celestial bodies. One of the most likely theories was proposed by Egyptologist Kate Spence. It involves using polar stars, while today we know Polaris as the northern guide. About 2,500 years ago, the closest to the north celestial pole was the star Thuban, The Egyptians could use the brighter star in Ursa Major Mizar and the star Khotab, which was near Thuban. They could set up a long rope with a plumb bob and observe when Mizar and Khotab aligned on both sides of the vertical line. This allowed precise determination of the direction to the North Pole. This theory is supported by the fact that small variations in orientation between pyramids of different pharaohs correspond to changes in these stars' positions. Due to precession of the equinoxes, this indicates that the Egyptians indeed used astronomy for orientation. Other, simpler methods, such as observing the sun's trajectory during equinoxes, could also be used for approximate orientation, more speculative and widely known as the Orion theory. It was popularized by Robert Bauval in his book The Orion Mystery. This theory claims that the arrangement of the three main pyramids on the Giza Plateau, Khufu, Khafre, and Menkaure, is an exact copy of the arrangement of the three stars in Orion's belt, Mintaka, Taumilim, and Kaunatak. According to this theory, the Egyptians deliberately planned the pyramid placement to reflect a celestial map, symbolizing religious concepts associated with the god Osiris, who was believed to reside in the constellation Orion. However, this theory has been almost unanimously rejected by the scientific community for several compelling reasons. First, despite general similarity, the arrangement of stars in pyramids is not perfect. To achieve a match, one diagram must be flipped upside down. This is a dubious step. Second, there is no textual or archaeological evidence confirming that the Egyptians had such a connection between pyramids and Orion. Third, the theory requires dating events thousands of years earlier than the official chronology of ancient Egypt. This contradicts all available data. As a result, the Orion theory remains on the periphery of academic discussions, and is an example of how a mature eye can see familiar figures in a chaotic set of points. This is the pareidolia effect. Other astronomical aspects of pyramids also raise questions. The air shafts exiting the king's and queen's chambers in the Great Pyramid have long been considered ventilation shafts. But their slope and external blocking make this unlikely. Scientific studies have shown that one air shaft is directed at the star Sirius, that is, Anubis, and the other at the constellation Orion, that is, Osiris. This confirms the importance of astronomy for religious practices, but their practical utility is doubtful. Since they are blocked, conducting full astronomical observations from inside was impossible. Most likely, their direction was ritual, symbolic, and they served so that the pharaoh's breath or soul could travel along this magical path to the celestial gods. There are other theories related to astronomy. For example, the assumption that the arrangement of all pyramids of the Old Kingdom corresponds to the arrangement of certain stars, which, however, also lacks serious evidential basis. Thus, the astronomical mysteries of pyramids have a dual nature. On one hand, they demonstrate the real and deep knowledge of ancient Egyptians about celestial phenomena, which they successfully used to achieve precise geometric and ritual orientation of their structures. On the other hand, any attempts to find in this a complex but unconfirmed by text system of astronomical maps or codes are most likely the result of speculative thinking. Scientific explanations, based on observations of polar stars and the sun, are sufficiently convincing to explain how pyramids were built with such high accuracy. Speculative theories, such as Orion, although attractive to the general public, do not withstand criticism from the academic community due to lack of evidence and the need to introduce arbitrary assumptions. Understanding how the Egyptians used astronomy opens to us a much more interesting and complex picture of their world than any of the mysterious theories. Now let's describe the astronomical aspects in more detail. Precise orientation to cardinal directions was achieved by observing the motion of polar stars. Thuban, Mizar, Khohab are the sun during equinoxes to determine the direction to north. Here there is no scientific explanation since astronomy was a real tool. The arrangement of Giza pyramids may be a random coincidence, a reflection of other plans unknown to us. The Orion theory says that the pyramid arrangement is a map of the Orion constellation, symbolizing Osiris. Astronomical air shafts had ritual direction for the pharaohs sold to celestial gods. Sirius and Orion. Practical utility for observations is doubtful due to blockages. The theory of using air shafts as ventilation or for other unclear technological purposes. The height and sizes of pyramids correspond to religious and symbolic concepts, as well as astronomical concepts, but are not precise codes. Theories that pyramid sizes encode physical constants, speed of light, Earth's radius, or geometric constants, pi. The era of noninvasive research, revealing hidden voids with muon tomography, the most captivating and scientifically confirmed discoveries concerning the internal structure of pyramids have been made in recent years. Thanks to the application of advanced noninvasive research methods, traditionally, pyramid archaeology was limited to visual inspection of known premises and searching for new entrances, which often lead to dead ends. However, a new approach based on particle physics has allowed peering inside the monuments without causing harm. This breakthrough began with the Scan Pyramids project. Since 2015, it has used various technologies, including muon tomography, to search for hidden voids. These studies have led to several significant discoveries. They have changed our understanding of pyramids' internal structure and opened a new era in their study. Muon tomography is a method based on using muons. These are elementary particles. They constantly fall to Earth from space. As a result of cosmic rays colliding with atmospheric molecules, these particles have high penetrating power and can pass through large amounts of matter. When a muon passes through a dense area, such as stone, it interacts more often with atoms and is absorbed. When it passes through a void, it passes with fewer collisions. By installing detectors in known pyramid premises, scientists can measure the number of muons reaching the detector from different directions. By creating a density map, areas of reduced density can be detected. They correspond to hidden voids. This idea was proposed back in 1968 by physicist Luis Alvarez, but only now has become possible thanks to the development of modern detectors. The main and most significant discovery of the Scan Pyramids project was the detection of a large horizontal void. It was named the Big Void in the Great Pyramid of Khufu. This discovery was announced in November 2017 and became one of the main scientific events of the year. The Big Void is located above the Grand Gallery and has a length of at least 30 meters, about 100 feet, and a shape similar to it. Its size makes it one of the largest structures inside the pyramid, and its discovery forced a reevaluation of our knowledge about the architecture of the Great Pyramid. It is important to note that the discovery was confirmed by 3 independent scientific groups, each using different types of muon detectors: nuclear emulsions from Japan, Myrmevis gas detectors from France, and scintillation detectors from Japan. This multi-level confirmation significantly increased confidence in the results and showed the reliability of the method. In addition to the Big Void, other, smaller voids were discovered. In 2016, a space behind the chevron structure on the northern facade of the pyramid was found. Later named the North Face Corridor, it has a length of about 9 meters, width of about 2 meters, and is located directly behind the known chevron structure. In April 2023, this discovery was confirmed in a unique way. A video camera was inserted into a narrow gap in the wall. It allowed obtaining the first-ever images from inside this hidden space. The video shows rough, unfinished walls and a chevron ceiling similar to the external structure. This indicates that the space was deliberately hidden and never intended for viewing. These discoveries in the Great Pyramid served as a prototype for applying similar methods to other pyramids. In 2023, as part of the same project, 2 air voids were discovered on the eastern side of the Pyramid of Menkaure. These voids, located behind the smooth granite casing, have sizes of about 1.5 by 1 meter. and 0.9 by 0.7 meters respectively. Their discovery was an important step, since they confirmed the hypothesis of a possible second entrance to the pyramid, which could have been sealed along with other entrances. These discoveries have led to new questions and hypotheses about the purpose of these hidden voids. The scientific community proposes several versions. One of the most plausible is that they are structural elements, intended for distributing load from upper parts of the pyramid and preventing collapse of the Grand Gallery or other heavy structures. Another hypothesis suggests they could have been part of construction technology, for example, serving for moving blocks, or left for builders' convenience. However, none of these hypotheses can yet be definitively confirmed. The main mystery is that these voids are not random empties, but have regular shape and location, indicating their intentional nature. In addition to muon tomography, other non-invasive methods are used to study pyramids. Microgravimetry measures very small changes in the gravitational field caused by voids with lower density. Theoretically, the big void could be detected this way, but in practice, it would require ultra-precise measurements in conditions of the pyramid's complex and heterogeneous structure. Ground-penetrating radar and ultrasonic testing are used for detailed study of surface layers and walls. As in the case of the Pyramid of Menkaure, these methods are well suited for finding voids near the surface, but have limited penetration depth. In the future, these methods are expected to develop and be applied in combination to create a more complete and accurate picture of pyramids' internal structure. Scientists are already planning to develop even more sensitive muon detectors, and even create full three-dimensional tomography of the entire pyramid. But the biggest step forward will be the use of miniature robots, capable of entering newly discovered voids and collecting information that will allow finally unraveling their purpose. Thus, modern science has shifted from searching for legendary treasure rooms to systematic, scientific investigation of pyramids' internal architecture, and these studies promise many more discoveries in the coming years. Now let's describe the key discoveries in more detail. The Big Void was discovered in the Great Pyramid of Khufu. Using muon tomography with 3 independent detectors, its size is at least 30 meters in length and about 7 by 7 meters in cross-section. It is located above the Grand Gallery, likely a structural element for load distribution. The North Face corridor, also in the Great Pyramid of Khufu, discovered by muon tomography and visual inspection with a video camera. Its size is about 9 meters in length and about 2 meters in width and height. It is located behind the northern facade, behind the chevron structure, likely a construction void or hidden structure. 2 voids on the eastern facade discovered in the Pyramid of Menkaure. Using muon tomography, electrical resistivity, ground-penetrating radar, and ultrasonic testing, their sizes: first 1.5 by 1 meter, second 0.9 by 0.7 meters. They are located behind the smooth granite casing, likely a possible second entrance or construction void. Modern perspectives and future pyramid studies. The analysis of Egyptian pyramid mysteries shows that we are in a period of active scientific discoveries. It is radically changing our understanding of these monuments. If in the past the main focus of research was on searching for legendary treasures or verifying speculative theories, then today's science has shifted to systematic, multi-level study of pyramids. Using advanced non-invasive technologies, the future of these studies will be determined by 2 key directions: further revelation of hidden void mysteries, and deepening our understanding of the construction process through synthesis of archaeological, geological, and engineering data. The main direction of future research is studying discovered hidden voids, such as the Big Void in North Face corridor. At present, their purpose remains the main mystery. The final solution to this mystery is possible only through direct visual inspection of these spaces. For this, miniature robots are being created and developed, capable of penetrating narrow gaps and transmitting back images and data. These robots can be equipped with cameras, air chemical composition sensors, laser scanners for creating three-dimensional models, and even manipulators for collecting samples. The first successful attempts to introduce robots into pyramids have already been made. For example, in the air shaft of the King's Chamber, there. The University of Leeds robot discovered a small repository with symbols, but was stopped by a second stone slab. Similar expeditions into the Big Void or North Face Quarter could provide decisive answers. We may see whether these voids are constructional, structural, or ritual. Possibly, they contain new, yet unknown to us ritual objects or texts, which could supplement our picture of Egyptian religion and culture. The second important direction relates to deepening understanding of the construction process. Although the theory of workers and ramps is dominant, questions remain regarding precision and speed of construction, especially when lifting the heaviest blocks. Modern studies, such as the Harvard Giza project, use three-dimensional visualization to create interactive models of the Giza complex. Integrating data from archives and field studies, these models allow not only reconstructing the pyramid's appearance, but also analyzing their architecture. For example, investigating how light entered underground premises at different times of year, which may help establish the chronology of neighboring tomb construction. Computer modeling, as in the case of the integrated edge ramp theory, allows testing hypothetical construction scenarios and evaluating their engineering viability. Such studies show that, despite apparent simplicity, the construction process was extremely complex, required the highest degree of organization and engineering knowledge. Future research will continue in this direction, using climate data. For example, ancient Nile levels, which were a decisive factor for material transportation, logistics, maps of ancient waterways, and archaeology, analysis of traces on construction sites, to create increasingly accurate and detailed models. Nevertheless, it is important to recognize that not all theories proposing revolutionary explanations are scientific. Pseudoscientific theories, such as the idea that pyramids were energy stations, are the hypothesis of a hydraulic lift for the step pyramid, or at different stages of viability. The hydraulic lift theory, although a scientific hypothesis, requires further verification and is not yet an accepted fact. At the same time, theories about energy stations or alien origin of pyramids have no evidential basis and should be regarded as cultural phenomena, not as archaeological facts. Critical thinking and understanding the differences between scientific hypotheses and speculative theories are key for understanding the true mysteries of pyramids. In conclusion, it can be said that pyramids continue to reveal their secrets, but the